आता या व्हिडिओ लेक्चरमध्ये आपण स्केलर आणि वेक्टरवर आधारित असलेली काही न्यूमेरिकल्स पाहणार आहोत. यातलं पहिलं न्यूमेरिकल हे ट्रायंगल लॉ ऑफ वेक्टर ॲडिशन वर आहे आणि यातली गंमत अशी आहे की आपण ॲडिशन वरून सबस्ट्रॅक्शनची कन्सेप्ट इथे मांडणार आहोत. पहिलं न्यूमेरिकल काय म्हणते की यू आर गिवन 3 वेक्टर्स, vector AC, vector AB and vector CB, and the question asked is you have to express vector AC in terms of vector AB and vector CB. The job is simple. For that what we will do, we will apply triangle law of vector addition. According to triangle law of vector addition, if two vectors in magnitude and direction are represented by adjacent sides of triangle taken in order, then the resultant in magnitude and direction is represented by remaining side of the triangle drawn from initial point of first vector to end point of second vector. असा विचार केला तर इथे काय होईल, पहिल्या वेक्टरच्या एंड पॉइंट पासून दुसरा वेक्टर असं जर विचार केला तर इथे सी पासून दुसरा वेक्टर सुरू होतो, म्हणून हा फर्स्ट वेक्टर पकडला जाईल, हा सेकंड वेक्टर पकडला जाईल आणि हा या दोघांचा रिझल्टंट वेक्टर आर असेल. मग आपल्याला काय लिहिता येईल, वेक्टर AC बाय ट्रायंगल लॉ ऑफ वेक्टर ॲडिशन, वेक्टर AC प्लस वेक्टर CB इज इक्वल टू वेक्टर AB, बिकॉज फ्रॉम द एंड पॉइंट ऑफ वेक्टर AC the second vector will start CB. Then if these two are the two sides of triangle taken in order, then the resultant will be AB, which start from initial point of first vector and ends at the end point of the second vector. But what is asked in the question is that you have to write vector AC in terms of AB and CB. Therefore we will write it is vector AB minus vector CB. Therefore, what vector AC is equal to? Vector AC is equal to vector AB minus vector CB. Like this, you are able to perform the subtraction of vector using triangle law of vector addition. This is one more example here in which by making use of triangle law of vector addition we have to find out the resultant of all A1, A2, A3, A4 vectors. The resultant that we got is also expressed in terms of Polygon method of vector addition. इथे 4 वेक्टर्स दिलेले आहेत A1, A2, A3, A4 आणि ट्रायंगल लॉ ऑफ वेक्टर ॲडिशनच्या मदतीने आपल्याला या 4 वेक्टरचा रिझल्टंट वेक्टर काढायचा. दॅट वी विल डू इन अ व्हेरी सिंपल मॅनर. फॉर दॅट व्हॉट वी विल डू, लेट अस कन्सिडर A1 and A2 आर द 2 साइड्स ऑफ ट्रायंगल, देन द रिमेनिंग साइड ऑफ द ट्रायंगल इज OB. लेट इट इज रिप्रेझेंटेड लाइक दिस वन, इट इज वेक्टर OB. OB is the remaining side of the triangle for the triangle OAB. Now with this I will write vector OB is equal to, it is equal to vector A1 plus vector A2. This is one thing that I got from triangle OAB. Next what we will do, we will consider triangle OBC. In triangle OBC I will draw the remaining side as OC. This is OC. Now, in triangle OBC, side OC equal to vector OB plus vector BC. OC is equal to vector OB plus vector BC. But actually what OB equal to? Actually this OB equal to vector A1 plus vector A2 and what BC is equal to? BC is equal to vector A3. Now, if you think of triangle OCD, then OC is one side, CD is another side, and OD is the remaining side of the triangle. Therefore, I will write what this OD is equal to. OD is equal to vector OC plus vector CD. Therefore, what vector OD is equal to? This vector OD is equal to OC, vector OC. What actually vector OC is? Vector A1 plus vector A2 plus vector A3, and what CD is equal to? CD is equal to vector A4. Therefore, this OD is the resultant of all the four vectors. Therefore, I will write it as vector R is equal to vector A1 plus vector A2 plus vector A3 plus vector A4. Now, from this, I will state the Polygon law of vector addition. If number of vectors are represented by the adjacent sides of polygon taken in order, then the resultant of all the vectors is equal to the side drawn to complete the polygon from initial point of first vector to end point of the second vector. If number of vectors are represented by adjacent sides of incomplete polygon, then the resultant of all is the side drawn to complete the polygon from initial point of first vector to end point of the last vector. This is the Polygon law of vector addition, in which we are making use of the triangle law, and from that it is clear that the resultant of all the four vectors is vector R, which is one of the side of polygon which is drawn at the नदीचा प्रवाहाचा वेग असा आहे. This is the speed of the stream of a river, and this is, so rather it is the velocity of a stream of river, and this is the velocity with which the boat is moving in the river. The velocity with which the stream of a river is traveling is 5 km per hour, and velocity with which the boat is traveling is 20 km per hour. Here the direction of the water flowing through the river is given towards eastward. ही ईस्ट डायरेक्शन आहे, ही ईस्ट वेस्ट नॉर्थ साऊथ, आणि बोट मूव्ह होते ते नॉर्थ डायरेक्शन मध्ये. आता प्रश्न काय विचारलाय की प्रश्नात शेवटी असं विचारलंय, इफ boat enters the stream heading north, with what velocity will boat actually travel? बोटची ऍक्च्युअल वेलॉसिटी काय असेल? आता बोटची ऍक्च्युअल वेलॉसिटी काढायला बोट प्रवाहाच्या एक्झॅक्टली परपेंडिक्युलर आहे. हा पाण्याचा प्रवाह आहे आणि ही बोटची मोशन आहे. हा पाण्याचा प्रवाह आहे पूर्वेकडे आणि उत्तरेकडे बोटची मोशन आहे. तर या दोघांचा रिझल्टंट म्हणजे बोटची रिझल्टंट वेलॉसिटी म्हणजे ऍक्च्युअल वेलॉसिटी असेल. पाण्याचा प्रवाह बोटच्या प्रवाहाला मोशनला इफेक्ट करत असेल आणि बोट परपेंडिक्युलर वेलॉसिटीने जात असेल तरी त्याचा रिझल्टंट हा या दिशेत असेल, ड्रॉन फ्रॉम इनिशियल पॉइंट ऑफ फर्स्ट वेक्टर टू एंड पॉइंट ऑफ लास्ट वेक्टर. हे असं असणार. दिस इज द रिझल्टंट वेलॉसिटी विथ विच द बोट इज ट्रॅव्हलिंग. या फिगरवरूनच तुम्हाला असं लक्षात येईल की बोट टुवर्ड्स नॉर्थ है. दिस इज द डायरेक्शन ऑफ motion of a boat, and this is the direction, eastward direction is the flow of water in a river, and this is the velocity in which the boat is moving, velocity with which the boat is moving towards the north. Then this will give the actual velocity of boat. आता या फिगर वरून तुमच्या लक्षात असेल द रिझल्टंट ऑफ दिस विल बी वेक्टर r is equal to, I will call this velocity with which the water flows in a river, and v2 is the velocity with which the boat is moving. The resultant of these two perpendicular vectors, vector r is equal to square root of v1 square plus v2 square. Therefore vector r is equal to square root of, it should be 5 square plus 20 square. Therefore r is equal to under root of 25 plus 400. 5 square is 25 and 20 square is 400. Therefore, the resultant velocity with which the boat is actually moving is equal to under root of 425, and it should be equal to 20.61 kilometer per hour. Now, the actual path of the boat in which it is traveling, let it makes an angle theta with its initial path. Initial path is actually towards the north, but it is now moving northeast. In that case, actual you have to determine in what direction it is moving. For that we will determine this angle theta. To determine angle theta, I will write tan theta is equal to the opposite side v1 divided by adjacent side v2. For this right angle triangle, opposite side is v1 and adjacent side is v2, and therefore we will write this tan theta is equal to 5 divided by 20, and therefore tan theta is equal to 1 by 4, that is 0.25. Hence theta is equal to tan inverse of 0.25, and hence the actual path is equal to, it is making 14 degrees and 4 minutes with the vertical arc, making an angle of 14 degree and 4 minutes in the direction, making an angle of theta in the northward direction. This is how to determine the resultant velocity with which the boat is moving and in what direction the boat is moving. या प्रॉब्लेम मध्ये आपल्याला काय विचारलंय, एक वेक्टर दिलेला आहे. हा वेक्टर आहे, वेक्टर ए बरोबर आहे 3i + 4j. आता याच्यामध्ये वेक्टर ए चे दोनच कंपोनेंट दिलेले आहेत. एक एक्स कंपोनेंट अलॉंग एक्स ॲक्सिस 4i आणि दुसरा वाय कंपोनेंट अलॉंग वाय ॲक्सिस 4j. आता हा 3i + 4j दोनच कंपोनेंट असलेला वेक्टर आहे, म्हणून हा वेक्टर इन अ प्लेन आहे. याच्यामध्ये एक युनिट वेक्टर आय आहे, आय कॅप आहे, आणि दुसरं युनिट वेक्टर जे कॅप आहे. म्हणजे हे XY प्लेनमध्ये, कारण I कॅप अलॉंग X ॲक्सिस, J कॅप अलॉंग Y ॲक्सिस. आपल्याला विचारलेल्या प्रश्नात काय आहे की फाइंड युनिट वेक्टर अलॉंग वेक्टर ए. तर युनिट वेक्टर काढायसाठी बेसिक काय, अ वेक्टर ए can be split into its magnitude of vector A into a unit vector. This is unit vector in the direction of A. May I write this as UA? UA represent unit vector in the direction of A. To determine unit vector in the direction of any vector, U cap is equal to, it is vector divided by its magnitude. Vector A divided by its magnitude A. How to determine the magnitude of a vector? Magnitude of a vector in a plane is given by, it is equal to vector under root of ax square plus ay square is equal to square root of ax is 3, square of 3 is 9, ay is 4, square of 4 is 16. Therefore, it should be equal to square root of 25 and its same is 5. Magnitude of A is 5. Therefore, from this I will write unit vector U cap is equal to vector A, it is 3I cap plus 4J cap divided by 5, that is magnitude of A. Therefore, unit vector along A, U cap is equal to 3 by 5 I cap plus 4 by 5 J cap. This is a simple method to determine unit vector in the direction of a given vector. What thing you have to do is that only you have to find out the magnitude, and vector divided by its magnitude will give a unit vector in that direction. आता हा प्रॉब्लेम तसा सोपा आहे बरं का. दिस इज व्हेरी सिंपल प्रॉब्लेम. व्हॉट इज आस्क्ड इन दिस प्रॉब्लेम इज whether these two vectors are of equal magnitude, this is one thing, and if they are of equal magnitude, whether they are actually equal or not. We will see whether the magnitude of the two vectors is same or not. Here again it is I cap and it is J cap, it is I cap and this is J cap. It has only two components, therefore it's in a plane, and the unit vectors are along x and y axis, therefore this vector is in xy plane, this is also in xy plane, both the vectors are in xy plane. This is the one thing that you have to remember, both the vectors are in xy plane. The magnitude of vector A, I will write it is as vector A is equal to square root of, I should write it as ax square plus ay square. It should be equal to, here nothing is there, therefore it is in the multiplication, it should be 1 and it should be 2. Therefore 1 square plus 2 square, it should be equal to square root of 1 plus 4, it is equal to 5. Magnitude of vector A is 5. What about magnitude of vector B? Magnitude of vector B, it should be bx square plus by square. It should be equal to square root of bx is 2 square plus, here by is 1, it is equal to 1 square. Therefore it should be once again it is 5. From these two, what I will write? Magnitude of vector A is equal to magnitude of vector B. No doubt about this one. But what you will see that this AX and BX are not same, as AX is not equal to BX and AY is not equal to BY. The component of A along X axis AX and component of B along Y axis BX. AX is 1 and BX is 2. Similar to that, component of A along Y axis 2, component of B along Y axis is 1. Again, these two are not same. As the components are not same, I will say that vector A is not equal to vector B. They are same in direction, but not necessarily they are equal, because their directions are different, because its component has the different values. I hope you might have followed this one. इथे काय झालंय, दोघांचं मॅग्निट्यूड जरी सारखं असले तरी त्यांचे कंपोनंट्स सारखे नाही आहेत, म्हणून आपल्याला इथं असं म्हणता येईल की ही दोन्ही वेक्टर्स इक्वल नाही आहेत, कारण त्याच्या दिशा वेगळ्या असणार आहेत. ते वेगळ्या दिशेत आहेत, आणि दिशा वेगळ्या असतील तर वेक्टर्स वेगळे असतात, सेम नसतात. ही गोष्ट तुम्हाला लक्षात ठेवायची.